Is there a disco ball or something? It's in the bottom. There's a switch in the bottom. So I was told.
I will. Good morning, everybody. Sorry. Welcome to Scale Night 16. If you're like me, who wear many hats, or you've inherited a daunting role to be a DBA, you've come to the right place. Sophia is going to help us. Silvia is going to help us kind of navigate through that that daunting task. So without further ado, Silvia, welcome.
Thank you. Thanks, everybody. Can you guys hear me okay? Yep. So, I'm here to talk to you about how you can become a MySQL guru, or what is also known as growing pains with databases and lessons you've learned. Yep. First, let me tell you a bit about myself and why am I talking to you about this. My name is Silvia Botros. You may know me on Twitter as DB Smasher. I am currently a principal DBA at SendGrid, and I have been with them for a little over 6 years now. Before I joined SendGrid, I accidentally became a DBA. I started off as a now completely forgotten CDN as a software engineer. I was in charge of some UI Django code and Python code. Someday, about 9 months in, there were performance problems, and within a couple of days, I was knee-deep in MySQL documentation because we realized it was a database, and the rest, as they say, is history. A little bit about SendGrid, if you haven't heard about us. We are an email infrastructure provider. What that means is that we are a middleman for our companies who try to get their customer communication in the inbox without having to build all the infrastructure entailed to dealing with so much email. We have more than 63,000 paying customers in over 100 countries. We process more than 40 billion emails per month. And these are just a few of our customers who are by now household names. Another stat that I found out recently is that we apparently have sent emails to more than half of the unique email addresses in the world within the last year alone. And so in the process of getting to that very large scale, we learned a lesson or two. So who am I here to talk to? You're an engineer at a rapidly growing company. You are suddenly in charge of databases because nobody else is. Your ops team is a single-digit number of people. They are busy building an infrastructure, whether in Amazon or self-hosted, and it's growing very quickly. And you don't have a DBA on staff yet. However, every time there's conversations about an outage or why a certain feature hasn't come out yet, the database comes up. Yeah, we've all been there. So what are we going to talk about today? First, I'm going to tell you some basics, some tips about schema design, some metrics that you should probably always track, and some things that you need to monitor. Then we're going to branch out a little bit more into architectural best practices that will help you scale your database. And then we're going to talk about what is the point where you do need to get a DBRE, and what are the things you should look for in that person that will help your company and your team grow. Let's start off with some schema design. In MySQL, primary keys are your friend. The most used engine at this point in MySQL is called InnoDB, and primary keys are also known as clustered indexes. And that means that every leaf of that index tree also carries a full copy of the row that this leaf is pointing to. In non-DBA speak, that means if your query is going to filter directly on the primary key value, you can get the entire row with a single lookup, which is the fastest query performance you can achieve, unless your database is DevNull, but then that's not a relational database. So it's not easy to guarantee that you're going to always query on the primary key. One way you can do that is to just avoid auto-increment keys entirely. That would be great if you could do it. You pick a unique key that exists in your table, a combination of columns that are unique together. MySQL allows you to do that. Most modern ORMs will also allow you to do that, but that's not always an option. Sometimes that is a value that is too large and by itself will cause performance problems. If you do end up having to use an auto increment key for your primary key, you should always remember to make it unsigned. One of the tricks and traps in MySQL that are less known is that integer values are presumed signed unless you specify otherwise. And what that means is that if you define an auto increment key and forget to mark it unsigned explicitly in your definition, you're coming out of the gate with a primary key that can only use half of its key space. Do you know what happens when your primary key runs out of key space? Sorry. You'll stop taking new rows. You try to insert to the table, and it will give you this very vague error of you reached the maximum value for column X. And you will have a red outage on your hand because you will now have to stop all writes to do an alter table to change the type of the primary key, and things will be down for quite a while. And I'm assuming once you've reached that maximum value that you have a large table on your hands. Ask me how I know about that one. Some more schema design tips. Always set a default. MySQL tries to help you out by not being so restrictive on how you define things, but on the other hand, that flexibility can be a problem down the line. Null is a default for most things, but a lot of times null doesn't make any sense. If you're defining a Boolean column, what does null even mean? You should always have a default that makes sense within the context of your data. Null should be the exception, not the norm. Timestamps are a good friend, especially now in current versions of MySQL. It doesn't have any more restrictions that don't make much sense. They used to only allow like one column that is one timestamp, and only one of them can have current timestamp. These are no longer the case. So it will help you a lot down the line if you actually set timestamps on all of your tables that will tell you when a row was added and when the row was modified. I'll show you later how those timestamps can be really helpful in pruning down your critical databases to a reasonable size. Don't sweat the
The one up at the top about null is the worst. I use null so that I can use the same field in more than one query, but it doesn't show up when I'm looking for this field, whereas it does for something else. So I use them all over the place.
It has implications on how the query optimizer is going to try to figure out how to decide the query plan. It may get in the way of using certain indexes.
Okay.
So sometimes just an empty string will probably be a useful thing. Context, of course, is everything here.
What was it last part?
Context is everything. So it's like what is the actual context of the data in there? What is the application doing? That will help define. And I'm not saying do not use it as a rule. The biggest rule in database design is it depends. But it's important to know why you're using the null and not just accept that null is the default. Be deliberate about how you're using it, is what I'm saying.
Okay.
Another thing you need to keep an eye on is don't sweat the indexes. It is impossible to come out of the gate on day one with the table with all the indexes you will ever need or not need. It's important to understand that there will be changes down the line as your user base expands and as your use cases change. And so there will be maybe one or two obvious cases. Say it's a user table and the username is an obvious one you want to index on, but done is better than perfect. And always accept that you will have to go back later and look at your logs or look at your slow performing queries and decide later how to change things. This is a fun one. There are a lot of synonyms in MySQL, and by that I mean MySQL doesn't explicitly define certain types. A good example of that is Boolean. There is no explicit Boolean in MySQL. When you define a Boolean in a table, under the hood is actually a tiny int. And tiny int, if it's unsigned, can store up to 255. That's a lot of possible values for a Boolean. Now, it may seem like a really cool flexible thing to do, to just start using it as a higher with more values than the two, but if your column name is also named is active and it sounds like it's a Boolean, you are going to be setting everybody up later for some serious confusion with how you use that column. So word piece of advice, even if the synonym allows you to use this value for more than what it actually sounds like, that's not a good thing to do. Because down the line, your DBA is going to try to look at this table and figure out how to optimize some query. She does a select distinct on the isActive column, and 12 different values come out. Ask me how I know about that one. Let's move on to metrics. There's a lot of metrics that you can track in MySQL, a lot of things that it actually exposes to you. I'm not going to be comprehensive about it because we could spend all day about that, but I'm going to cover a few that are super important for everybody to track no matter what your context is. The first two that are related that I'm going to talk about are threads running and threads connected. These are very close, but you will track them for completely different reasons. The first one is actually a subset of the second. Threads running is actually showing you what is the work in progress in your database. It's showing you how many threads, how many connections are currently doing work. And so you always want to keep that value low. And if it starts going up very often, it's a sign that things are overall slowing down, because it means that the queries are not starting and finishing real fast. That cat picture is really threads running. That's a mutex that they're fighting over. Reasons that you could have an elevated number of threads running is, in a writes context, it could be a mutex, could be a lock that there's contention of. One of the good examples of that is foreign keys. They are notorious for causing write contention because there will always be this check between the tables to make sure that the relation exists, and so that will get in the way of the writes and can cause a lot of writes to stall waiting for each other. Auto increments have the same problem sometimes. If you have enough inserts trying to go at the same table, there's a single mutex for the auto increment value, and they can all start waiting on that one. In a read context, you could have elevated threads running because of disk IOPS. If you have a bunch of reads that are trying to scan a number of secondary indexes, the number of row scans can multiply to the millions sometimes. And in that case, if enough of those queries are happening at the same time, they're all doing that scanning independent of each other. And that way you can completely saturate your disk array with read volume. And next thing you know, all of those reads are just stalling. Moving on to threads connected. Threads connected is similar, but not exactly the same. It is actually a count of all of the open connections, whether they're working on a query or sleeping. And that one is actually more sinister. The reason it's going to hit you at the worst possible time is because MySQL has another config called max connections that I'm going to talk about later that specifies how many connections can be opened to the server at any given time in total. If your threads connected is climbing continuously and starts getting too close to that, you are ramping up for an outage when your traffic spikes. So it's important to always keep an eye on threads connected and to make sure that it doesn't get too close to your max connection value. Another good one is disk IOPS. Now, a few years ago, we used to say that, oh, well, SSDs are getting cheaper. We don't have to worry about IOPS anymore. We can just like stick flash storage on anything that needs a lot of disk reading, and so we won't have to trash the disk. Databases will use them if they find them. Nothing, even if you get like those fancy Fusion I/O things, you can saturate the IOPS of a disk array with enough read contention or with a schema that is not super well designed or using large text blobs. So always keep an eye on disk IOPS because you'll be surprised how fast you can saturate that under high load. I will show you a really cool graph later that shows how you do that. So this is one of the databases that I used to manage at SendGrid. I have redacted the host name to save the innocent. This box is not a VM or like a small commodity server. This was a box that had 48 SSD drives, 3 RAID cards managing the entire stripe, and I don't even remember how many cores. But it had a schema that used heavily JSON blobs and that would scan on the order of 10 to 20 million rows per query. And so that happens. And this was a common occurrence, by the way. The moral of that story is that nothing is unlimited. Your resources are always limited, no matter how cool the technology behind the hardware is. Some more metrics. Disk space growth and the thresholds that you alert on disk space for. MySQL is notorious for one thing. When it takes up disk space, it doesn't give it back. But at the same time, if you want to alter a table, you are required to have free disk space in the OS that is equal to that table size. So say you're trying to alter a table that is 500 gigabytes, you better have at least 500 gigabytes free on the host to be able to make that change. And it doesn't matter what tool you're using to make the change, whether it's a blocking alter table or you're using an online schema change tool like the ones I'm going to mention later. So tracking your disk space growth, how fast you are eating up disk space on that database is super important. You don't want to find yourself where there's an emergency or there's a feature that needs to come out tomorrow and you're trying to do an alter and oops, we don't have enough disk space to actually make this change. This is one of the rate at which disk grows should quickly point you towards the priority of whether you need to vertically expand the host that you're running your databases on, or more preferably find ways to prune down your data. And also, this is one of those things which will show you a sign that your business might be ready for a data warehouse. Most companies, when they first start, they don't think about data retention issues. They don't think about when they need to age out some of their tables. And so next thing they know, within a year or so, they find themselves treating the database as both business critical and data warehouse, which is a really bad place to be. This is a very important rule. Things like disk space growth and how fast it goes, and data retention and how to rotate data out, which I'll talk about next, are super important in making that distinction and helping your business separate those two concerns so that they don't clash in their needs. And by that, we go to data rotation. Remember when I mentioned timestamps? Those become super important down the line. If your tables already have on the markers where you can easily tell how fast you're adding rows and how often you're changing rows, you can quickly make decisions along which parts of that large table on your hands now needs to be aged out. You can start making decisions of, okay, data that's older than a year needs to go. I can start adding date-based partitions on these things so that I can easily drop the older parts without affecting the entire table. MySQL has some of this stuff in the box built in with it, and some of it you have to manage on your own outside of it. So it gives you the ability to do date-based partitions. You tell it you're going to have 20 partitions, one per week, and they go from one like 52 weeks ago till now. And next thing you know, your table is broken into 52 files. However, that is as far as MySQL will help you. The commands to manage those partitions are built in, but you have to figure out a way to automate how to use them, how to add partitions in the future, and how to age out the old ones. This is where a tool that most DBAs are familiar with comes into play. It's called PDB Parted. There will be links to these tools in the slides that I'm going to share online later, so you'll be able to find them. It's a tool called PDB Parted. It is Perl script that wraps those commands in MySQL. It helps put human-readable arguments on them. It can help you both add partitions in the future and to also age out and drop the older partitions based on the arguments that you give it. But still, at the end of the day, it's a script, so how are you going to run that? What you do is you wrap that script in one of your monitoring commands. In my case, and I'm going to link to a blog post that I wrote about this in the past, we use Sensu at SendGrid, and so what I do is the partition rotation is explicitly a Sensu check. What that does is that the command will run as part of Sensu, and so the monitoring framework that we have will take care of watching the exa code, making sure that it ran successfully. If it doesn't, it takes up the exa code and notifies us with whatever handler we decided is appropriate for that particular case. And that way, one, you automated your data rotation, and two, it is monitored, because cron is terrible at that kind of thing. Like I said, these are the links to those tools and to that blog post which explains this particular approach a little bit better. Moving on from metrics to architecture. This is going to be some larger aspect tips on how to get your database layer to scale longer. Be careful with ORMs. Now, I know that ORMs are a very easy way to get off the ground when a company is starting, and that's totally fine. But you cannot go into using them assuming they will work for forever. You need to be aware that there's going to be a point where your scale is going to mandate using something else because the ORMs make presumptions about how your databases look and what kind of traffic do you have that will at some point be a problem for you. Once you're hitting on the order of thousands of queries per second, it's going to become difficult to scale with the ORMs. And that's when you're going to need something like Proxy SQL. Proxy SQL has been around for a couple of years now. It is written by a former DBA, and it is not an ORM. You don't have to define to it in code what your table structure looks like. What you do is you just give it the backends. It has certain knobs that are more geared towards scale, and its feature set is geared towards large throughput far more than just the simplicity of I just want to talk to the database like it's an object. Things that Proxy SQL gives you, like caching. Now, I know that MySQL technically has a query cache, but it doesn't work. In fact, if you have it on, it will actually get in your way. There are mutexes around the query cache that cause reads and writes to slow down because all of those queries are trying to populate the cache, but the way it's engineered, it just never gets a cache hit. In fact, MySQL 8.0 is going GA sometime this year, and Oracle already announced that they're completely removing the query cache in 8.0. And their recommendation is to use Proxy SQL for caching result sets. You can control how the caching works in Proxy SQL using comments on those queries as part of your connection. And so you can determine how well they are cached, like how granular you want them cached, or how loose your query hit can be. It offers configuration changes with zero downtime, which means that if you decide one of your read replicas needs to be under maintenance for a bit, you can easily have Proxy SQL drop all the connections to that replica without affecting the rest of them. Raise your hand if you had to do a full business maintenance because you had to go restart HA proxy because HA proxy doesn't drop existing connections. Ask me how I know about that one. Proxy SQL can also do inline load shedding, and what that means is that it has its own monitoring logic towards all of the backends it's talking to. And so it can tell based on statistics that are internal to MySQL, like the performance schema and the MySQL variables, it can tell which of its backend databases is under load and which is less under load. And so it automatically fluctuates and sometimes can even shun a database backend that is super loaded until it can cool down and then start sending queries again. And so it can have a much faster feedback loop in protecting the query latency back to the application based on what it sees talking to the backend database. And it can be much faster about that than outside, out-of-band monitoring that runs on a schedule. Another really cool feature in Proxy SQL is connection mirroring. And that means that if you set the right query rules on it, it can mirror the same connection with the exact same queries to a completely different backend at the same time. A really cool use case for this is if you are trying to upgrade MySQL, another big minor version. You have a couple of replicas that are upgraded, but you're not ready just yet to send your customers to that upgraded one because you still haven't tuned the configs. Proxy SQL can, with very little work on your part, allow you to mirror that work over to that up to the upgraded replicas and basically watch the difference in performance real time. Moving on to more things in architecture, you have to always keep in mind that writes will fail. You cannot build a system where you presume all writes are going to always succeed 100%, especially if the data in question is business critical. This used to be difficult to work around in the past. People tried all sorts of things, like they would have their application just keep retrying, which is a really cool way to DOS your internal infrastructure. Or they would have a local state file on the application side that it tries to replay. Now you just made your application also sort of a database, and now you have to make sure that the application node doesn't die because you have state local to it that is super important to your business. Another thing that was my favorite was a fallback table on the same database that is ostensibly down. That didn't happen. So you have to be prepared for degraded modes, and you have to be prepared for what is now famously called event-based architecture. We now have things like Kafka with, explicit resilience and persistence promises that we can use to basically stack our events and be able to replay our writes to the database if needed. Because here's a dirty little secret. MySQL's goal is not being available all the time. MySQL as a data store is relational, and it is designed for consistency far more than availability. So you have to work around that and have the availability be designed into your system through other means. And that's what the combination of things like Kafka coupled with your database gets really into play and gets super important for you. Now, not everything can be asynchronous like that. You can't make all of the writes in your system just drop into a Kafka partition and then we'll deal with them later. Sometimes things are super obvious to the customer and you have to deal with it right away. And that's when read-only mode and degraded modes are super important. Say it's your sign-up page. The database is down. You can't write any sign-ups, but maybe have your sign-up page, send an email to support as opposed to just be a blank error page. So this is where you can get really creative with how you deal with failure and how you make things a little less impactful to the business. This is the kind of thing that engineers cannot alone decide or work on. This is where product gets involved as well, but that's this afternoon's talk. Oops. You need to shard your abstraction layer the same way you shard your databases. If you did all this work to split your data stores by function where signups don't impact statistics or user settings don't impact signups, but then your abstraction layer, whether it's ORMs or proxy SQL or what may it be, if that abstraction layer is one large cluster that everybody talks to talk to any database, you haven't really done anything. Because at some point, that abstraction layer is going to start having load problems. Its capacity might go down, and you don't know if it's because we have more signups or if because someone is trying to DOS the page, or if it's because there's real traffic coming through and we just made hacker news or something. So make sure that your abstraction layer is also sharded the same way your databases are, so that you can tell when each part of your product is gaining more traction and gaining more traffic than the other. Another important thing to keep in mind when you're designing your data store layer is that lag will happen. That's just a fact of life. Now, this is where ORMs can be super limiting for you, because a lot of ORMs give you a binary choice. You will either have the choice to send your reads to a read replica or you don't, across the board, which is a problem because not all endpoints are created equal. Some of your endpoints are going to be super sensitive to lag, like you have a user sign-up flow and the customer input some information and now they're moving on to the payment information, and now you can't have that customer just waiting until your database cluster is done with its lag. But then other endpoints are going to be super not that sensitive to lag. Like, I want to look at all of my stats for last year. I'm okay sending that query over and then waiting for it for a minute or two. You can't have both of those kinds of classes of endpoints be following the same binary choice. And that's where having a proxy like proxy SQL, where you can define rules like this and decide based on each endpoint whether you want certain sensitivity to lag or not to decide what you're going to do. But you can't just pretend that lag is not going to happen. Once again, this is one of those things that products will help you with. This is where conversations across the org and cross-functional things, cross-functional conversations can be super important because everybody needs to be on the same page and how this will operate. And no, it doesn't mean send all your reads to primary. We've tried that. Now, you need to understand that you will never have just one database or one database cluster. In fact, that's probably a sign of success when you start needing more than one database and more than one database kind. So be open to that. It should be fine that you have more database clusters because it's a sign of success. Now, that was a lot of stuff that I just went over. You can't do everything at the same time, and prioritization can basically sink or swim a business. So let's go over shortcuts that you can probably take, things you don't have to worry about from day one, and then things that you really should do from day one. You don't need to agonize over every column type. Memory is super cheap now. I've seen posts go up to 1 terabyte in RAM, and I don't know how many terabytes in disk space. So it's become less important to be super finicky about whether your integer needs to be an int or a big int. Things like that are less important now. The one caveat here is be careful with JSON blobs and large text types, because MySQL as a piece of software is still super inefficient in how it deals with them. But besides that, for the most part, you don't have to spend too much time on that part. There will always be changes down the line. You should accept the fact that you will always come back and revisit as performance trends appear from your real customer traffic and as your product grows. You don't have to tune every possible config. This is a big rabbit hole in MySQL. Now, in the next slide, I'm going to turn around and contradict that by telling you you can't not tune certain configs, but there's a specific subset of configs that you need to worry about. Going down the rabbit hole of tuning every possible config can be quickly a road to diminishing returns, and your time is an asset too, so you need to keep that in mind. Don't index all the things. Indexes are great for read queries, but they're not free. And sometimes it's going to be hard to tell up front whether a certain table is going to skew towards reads or skew towards writes. So like I said earlier, accept the fact that you shouldn't index everything and maybe revisit later if there's performance issues. Audit logging is really cool, but it's not as important unless your product is out of the gate super coupled with some compliance. For example, you're doing something that has to do with healthcare or payment processing. If PCI or HIPAA or something like that is part of your business model, sure, this is probably a thing that you should do from day one. But otherwise, it is a large project that you probably don't need to worry about right away. So more importantly, things that you should not take shortcuts on, things that you should do from day one. You should always set your database time zone and your servers to UTC. You'd be surprised how often I've seen that not happen. It's incredibly difficult to fix this later, and that's primarily why I mention it as a thing you cannot take a shortcut on. You can't afford not to track your auto increment key space on all your tables, because this will hit you at the poorest possible time. It's going to be when there's like a big flow of new signups when your user table run out of keys, and now you can't sign up customers. That's a big problem. And it's relatively easy to write a script that will just compare your current primary key type with the maximum ID that exists on the table. Do your future self a favor and get that one in your monitoring. Backup testing. Now, most of us now have our databases in the cloud, then it really makes backups and snapshots super easy. But unless you're testing those backups, they don't exist. You have to always, and not just test the backups, you're better yet to automate the testing of those backups. Grab the last snapshot, pull it up on an instance, and then destroy the instance once it comes up. It'll save you a lot of time. And your future self, when your company really succeeds and you have to do some audit compliance, they're going to ask you about backup tests. They're not going to just ask about making the backups. And that's when you're going to thank your past self because you've got that already down. I said I was going to contradict myself. So let me go over some configs that you cannot afford not to tune from day one. Turn off the query cache. And it's not one config, it's actually two things in MySQL. There is the query cache size and the query cache type. Even if you set the query cache size to 0, it will still get all tripped up on the mutex if your query cache type is not set to off. Hopefully soon this will no longer be a thing that we have to talk about and we will all forget the big disappointment that was the MySQL query cache. But for now, that is still a thing. You need to make sure you turn it off. Set your InnoDB buffer pool size. By default, in MySQL, up until now, the default size for this is 128 megabytes, which is really, really small. but I'm assuming it was set like that because VMs and dev environments on laptops. However, there is no production server that needs to be using such a small buffer pool. So you have to always make sure to set it. Um, Bonus points if you're doing this in config management and use math based on the existing RAM. But you got to be careful not to be too greedy with it either. You have to also keep an eye on how many connections you have to keep open from your ORM or your proxy SQL cluster, because there's an overhead to keeping the connections. MySQL maintains buffers on a per session basis as well. And so if you go too greedy with your buffer pool, and then you have a spike in traffic and a lot more connections are starting to open, you can actually cause your database to run out of memory, and next thing you know, the kernel has unkilled MySQL, and you're down, which is really the opposite of what you wanted to happen. So, sure. I used to do 80%. I have tamped it down to 70, mostly for reasons that have to do with our architecture. But yeah, that seems to be a good spot to start. Less than 50 is definitely not okay. So a big part of this is going to be, plus you, a big part of this is going to be what are you using for connections. Things like Eventdy, Python, and Twisted are notorious for opening connections and not closing them. But if you're, say, using the Go driver, it's generally better at closing them when they're not used after a certain age. And so the connection hygiene of your application layer is a big part of this. Set your MySQL process file limits. It is the year of 2018, and MySQL will still start with only 1,024 file handles enabled. Sadly. But because this is a fact of life, you got to keep an eye on it. Every connection that is open to the database server needs a file handle, which means that even if you tuned your max connections and you're tracking your sets connected, what you don't know is that thing is waiting for you in the grass out there. And your connections are like getting close to over to 1,000, and next thing you know, all of your apps are seeing this very strange error that says cannot create thread, and that's why. So a systemd services file, even a direct command to the shell from your chef run that will just set this all the time will probably save you a lot of heartburn down the line. And max connections. The default value for max connections in MySQL is still at 151. That is probably plenty for an old-style LAMP stack. But we are now getting into microservices, and everybody has on the order of 20 to more services talking to the one database. 151 is not going to be enough. So between process limits and max connections, you need to be careful what is your actual application behavior and how much do you really need. This is usually a game of resources. So you're going to also probably decide at some point whether you want things to fail quickly with hard limits like this, or whether you want to expand those limits but then watch your resources deplete. There's always a happy medium, of course. That was a lot of information. Now, this was definitely a lot of stuff, and not all of this will come up at the same time, but at some point it's going to start feeling like managing the database is literally a second job. And that's the point where you need a DBA. However, there's good reasons and bad reasons you want to hire one of those. Do not be that team. You don't want to hire a DBA because you don't want to worry about the database anymore. That is not a good reason. You're still going to need your engineers to be aware of how the database behaves, how it interacts with the code they wrote. You need the DBA for other reasons. Now, let me first go over some of the bad reasons you would want to hire a DBA on your team. To run schema changes. Now, everybody, me included, at some point has to write schema changes, has to run schema changes in production by hand, because automating schema changes to databases is scary. And at the beginning of the business life cycle, that's not what's going to help you the most to get more customers and keep your product going. So at the beginning, it's fine, but you have to accept that at some point you're going to need to automate this, and that automating it does not mean hiring a human to do it. Your team should be already familiar with tools that help facilitate schema changes, so they're not just going in by hand and running alters on production and stopping all traffic. Things like online schema change and Ghost by GitHub. There's also this tool called Shift by Square, which adds on a nice UI and the ability to review schema changes, and so it gives them some more transparency to everybody on the team on how the schema change actually gets through its cycle from laptop to production. You do not want to hire a DBA to be on call for databases. Now, when I say this, I'm not suggesting that DBAs are too cool for PagerDuty, but I am saying that they should not be on call 24/7 for everything database, and as soon as one of the database's pages, it immediately goes to the DBA. Because that's a quality of life thing, and DBAs deserve a balance in life just the same as your engineers. However, they are a perfect escalation point. What you need to see happen is if there's problems, your engineers have to first try to debug it, and then if they're stumped, they can escalate up to the DBA. Because I don't think I've ever seen a shop where they have a number of DBAs that is equal to the engineers. And so it doesn't make sense to have the one person on call versus all of the engineers taking a rotation that's like a few months long. You do not want to hire a DBA because no one else has time to take care of this. If the database and the data is the most important asset of the business, then it should get the same level of importance. And hiring someone is not an outsourcing solution. So now some good reasons. You need someone to set some best practices. What you need the DBA for is to help train your engineers on how to best engineer around the database and how to use MySQL the right way and when to realize that maybe MySQL is not the best tool for this particular part of the product. Like I said, they need to be an escalation point. You will need someone with expertise to help your engineers when they hit something they're not familiar with. If your engineers are new to scaling databases, if you're the kind of company that's seeing 40% growth every year, that's a large base, and not all engineers have had experience dealing with that. And so having someone who has done this before would probably be useful for them as a subject matter expert. Or you're solving really interesting and new problems, which is hopefully most of us. So who are you looking for when you're hiring for a DBA? There's a stereotype around DBAs that they always say no, and they're protecting their databases very carefully. That is not what you want. Once again, that is afternoon's talk, so you can find me there and we'll talk more about that one. You need someone who is enabling your engineering team, who is actually explaining to them how to do things, why things work a certain way. They need to be more than anything a mentor, because if your DBA is not leveling up your engineers on how to talk to data stores, then they're not really doing exactly what they should be doing. What you do not want is someone who's just maintaining your database super carefully by hand and nobody else is allowed to touch them. This is some reading material that I'm going to close with. These are super important, and I think they would be useful even if you're not looking to become a DBA down the line. The DBRE book came out late last year, I think, and it's super important. The two women who wrote it have really good perspectives on both NoSQL and relational databases, and so I think the advice in it can apply either way. More specific to MySQL, the second book is a classic. And then you'll find that the third one is a blog post by Charity, and it hit close to home, and I think it will for a lot of you in the room as well. It really talks about things that you got to watch out for if you just suddenly find yourself in charge of databases when you weren't planning to. And that's it. Thank you. Questions? Are there any questions? Thank you, Paul. Oh, sure. There's a mic here, too, if you'd like to come up.
How do I get to the links?
I'm sorry, I didn't hear the last part.
How do I get to the links that you showed?
To the links?
Yeah.
I'm going to share these slides online later. I'm going to tweet out a link, so you can follow me on Twitter or something at DB Smasher, and you'll find a link to the slides. And within it, you're going to find links to those resources. Yep, that is my handle right there. Any other questions?
Mine's more about MySQL Tuner, the infamous script that gives you mathematical equations and dumps it all in. Should anyone actually use it? Should it even be a blip on someone's wall, or should it honestly just be totally disregarded?
If you're completely lost, it's a good starting point.
Okay.
So if you've never done this before,
Okay.
and you know there's a problem,
Okay.
it's a starting point to start comparing, reality with what this thing is saying. But I don't advise towards using any of the things that are out there as, hard, fast rules.
Okay.
There were things that I used to do with databases before I joined SendGrid that I completely flipped over after about a year at SendGrid.
Right.
So
Makes sense.
what happens on the ground will a lot of times change things.
Okay. Thank you.
Hi, thank you for the talk. Just a quick question regarding the database time zone. You mentioned it's good to set it on UTC, but do you have any tips on how you could move an organization to use UTC when they're already accustomed to using something like Pacific, for instance?
Man, if you do, I'll pay you some money for that. It's really difficult because it's gonna become a problem. Here's the thing: if you're using a lot of datetimes don't even have a time zone attached to them. So you're gonna have to make sure that that you know what the time zone was from the beginning of this database's existence, and I guess do conversions is gonna be a large project. You'll have to do migrations and things like that. I don't believe there's anything out there that will just do this for you.
Thank you.